Welcome, everyone. This is Tornado of IP with Thoughtful Thursdays, our podcast. And we are here with our guest, Ken Malone, who is a really, really interesting guest for us because he has a very, very long, diverse background spanning industry and university. Ken brings very strong technical background with a PhD in chemistry, and then long industry background, well, not just coming from R&D to manufacturing to business, and then moving into a small consulting and business sector where he very successfully led a company called Early Charm that worked closely with the University Tech Transfer. And this is this really, really interesting and broad background is just a wealth of questions for us and for our audience. And I wanted to give Ken a little bit of a time to can you please tell us a little bit about Early Charm? What are your biggest and proudest accomplishments, and also what you're currently doing? Because this is not done yet. Ken's amazing career is continuing onto something really interesting.
Yeah, so Early Charm exists because of an intellectual property challenge, and that's that decades ago I looked at universities and government labs, and 95+% of their inventions just sit on the shelf and never get licensed and never move forward. And of the ones that do get licensed to move forward, the success rate isn't so impressive. And I looked at that and said, look, there's got to be a better, different way to address the issues here. And as I really dug in, I realized that the success stories coming out of tech transfer were all linked to basically this venture capital model where venture capital funds it, and it either takes off or it doesn't. It fails fast, or it's tremendously hugely successful. But only a couple percent of inventions at these places are appropriate for venture capital. So all of these other inventions don't have a business model that allows them to come out of the universities and be successful. And so I looked at that and said, look, can we come up with a different model? And that's exactly what we did. And I don't know, we could spend the next 3 hours talking about that, but just suffice it to say that we figured out a model for that. Over the course of the last 14-ish years, we licensed over 45 patents and other pieces of intellectual property from universities and a few government labs. We have 120 products currently under development and 15 fully commercial. And one of those fully commercial products actually uses the patent that we licensed from the university. The other 14 are all pivots. And you can do the math pretty quickly. 120 products under development, but only 50-some, 40-some licenses. That's another 80-some pivots, right? So a lot of things go on. It is kind of a fun chaos that ensues when we do those licenses and build the businesses around it. But that's what I've been doing for 14+ years. And today I turned the business over about 4 or 5 months ago to my number 2, who is now the number 1 running the business, and she's doing a stellar job with it. And I now do consulting work in the area of advanced manufacturing, and I call it advantage manufacturing, helping especially economic development agencies understand how to build manufacturing bases in their communities and create jobs that actually are worth having. That's all I do.
Okay, great. So let's dive into some of my questions, and maybe some of them you touched a little bit of in your intro, but maybe you can expand on where do you see the biggest breakdown between a university discovery and a commercially viable business?
Yeah. So not surprisingly, there's lots of them. And the biggest one being that the inventor at the university very, very rarely understands the actual use case in the industry because they're just so disconnected from it. And that disconnection means that you can have a perfectly valid patent and still have it not make a lot of economic sense, right? So there's a big piece of that, but that is not explaining, I would say, most of the failure. It explains the obvious failures, right? But if it really explained the failure, then you would expect a tremendously huge success rate for universities where their surgeons are creating medical devices, because that's a case where the surgeon really does understand the market incredibly well. And in fact, I don't think in my life I've ever met a surgeon who doesn't have an invention. Smart people, they do the same thing over and over again, and they're going to come up with a better, easier way of doing things, right? And what you discover when you really dive into medical devices is that the method by which they reach market pretty much requires a pathway through venture capital and a pathway into all of the large medical device manufacturers or suppliers, right? So the Strykers and the Medtronics of the world. And so the failure with all of those patents sitting at the university is a failure to understand how you raise money in those spaces and what will get financed in those spaces and what won't get financed in those spaces. And so people think about the customer as the surgeon, right, for a medical device, or the patient with the medical device going into it. But it isn't. It's actually the venture capital and the medical device companies that need to license it. And so if you flip that and decide that's the customer, then my explanation of the failures occur because the inventor doesn't understand the market. That's where that failure breaks down, right? So that's the big thing.
Wow, this is very interesting. And I recall previous conversations we had where you told me that universities that have a medical school, you can really very distinctively look at their patent portfolios between medical inventions versus non-medical inventions as well. So I guess you might want to answer my second question for each of those pieces separately. So let's say you have a professor who has an exciting scientific result. What do you think they should do next before they start talking about forming a company or filing patents?
I think that the universities do kind of now get this right when they say, what does the professor do next? And that's like really try to understand who actually would buy this and why does it add value to them and these sort of things, right? The challenge for understanding it, though, is the big issue, because it's one thing to say, okay, I've got this potential invention. Let's go see if the market needs this, right? In some areas, that's incredibly direct and obvious. So if I've got a new therapeutic to attack prostate cancer, it's easy to understand what the market of that is. It's easy to understand what the current state of the art is. It's easy to get that information. And so you discover that it's really a question of, does the biology and the science all make sense? Then the market's there. Let's say that the professor is in the Department of Physics and he's got this really new cool quantum theory. And that quantum theory says, hey, I can measure or take a photograph of an object that is 50 miles away. And I have the ability to get rid of all of the air turbulence or the heat haze that would occur in that photo, so that when I see it, I'm going to see it with a lot more crystal precision. And I know exactly where it is. It didn't move because of heat haze, and it'll be right there. Okay, great. Who's the market for that? And what is that? And, we spent 3 years working on that project, and we never really actually found a true market. Lots and lots of people speculate and say, yeah, autonomous vehicles, they need that because, they're trying to navigate distances. The Navy needs it because when they target systems over the ocean, right? And it turns out that a lot of that is kind of sort of true, but it's also kind of very hard to figure out, is this actually a superior way of doing this? So not just is there a market for it, but is there a market in which this is a superior way of solving the problem? And the disconnect between the professor and what's actually going in the market is just cavernous, right? So that's the long explanation of how those two things kind of end up in different spaces.
Yeah, I mean, I kind of contrast, in my opinion, with what happens in a big company that has business people, strategic marketing, and then they'll have an R&D organizations where their leader is sitting in together with those business people. So they know what the business strategy is and where it is the business investing and their awareness of the market, which then drives the R&D organization, however narrowly or broadly that's allowed to happen. Chemical industry, that might be very, very narrow, but that actually informs then the IP strategy, how we can protect that area. So the patent is a result of the strategy, and not the starting point, but
not the other way around.
Yeah, but
no,
then
you bring up a really, really great point with this, right? And so if I look at a research dollar spent at a large corporation, and I say research dollar as something other than an incremental process improvement, right? Because we know incremental process improvements have great paybacks for large companies, and the overwhelming amount of research spent at a large company is on process or incremental product improvements. Because they're easy to track and they're easy to see, right? But true research, like developing a new product or developing an entirely new process, what you see happen is that they have incredibly high failure rates, but it's because of the way that failure is defined or success is defined. And success in that large company is defined as, well, you built the product we wanted to build for the market we want to be in, or you build a product that uses our current assets in the way that we want to use our current assets. But research, as we all know, doesn't work that way. You don't know what's going to happen. That's the whole point, right? But I think my observations, having worked for, a dozen plus years in large company research, is that you constantly invent really great new things that don't fit the company's interests. And so they get thrown on a shelf, right? And the funny thing is that the universities have exactly the opposite problem. The researcher invents something, and like every decent researcher at a large university who's got dollars of research grants behind them is going to have a couple patents. In fact, I think the ratio is something like $1.5 million of research funding leads to a patent at a typical university, right? I might be off by a little bit on that, but it's close enough, right? And so it's basically saying, look, I did this work, I discovered some stuff, I invented it, I've got a patent, right? But then the value for the university sits in that very, very narrowly defined patent, not in any other asset. And so the university only cares about, how do I market that particular patent? And so on one end, you've got a very, very market-driven invention process at universities where they throw everything on the trash heap that doesn't meet that market. And on the other side, you've got the universities that have no idea what the market is. They just have science and inventions, right? And in the middle ground, you have this really interesting opportunity in the startup space to play that fuzzy interface. And so that's really at Early Charm, what we were doing is we were playing that fuzzy interface. We would take things that the university kind of sort of thought was cool over here, and they never were, and took them in a different direction, right? But we had the freedom to do that. And you can't do that in a large company, and you shouldn't do that. And the university shouldn't behave any differently than they behave. So, we beat on universities a lot and say, you should do this better, but they're not doing anything wrong. They're just doing what they can do.
Yeah, and some of the most amazing inventions come out of things that, in the surface of it, you don't think it's valuable. Even the university doesn't think it's valuable. Like I think of Katalin Karikó, the Nobel Prize winner, mRNA vaccine, her fundamental research on that, she didn't get tenure at Penn. It wasn't valued. But, sometimes those kinds of things don't come out that they're valuable until much later.
Yeah, and they can't come out, right? This is this fallacy of like the stage gate process that every large company in the world has implemented, right? Which is that you can drive and focus innovation that's not iterative and it's not chaotic and it's not discovery oriented, and it's really kind of denying reality to pretend like it's anything else. So what you need to do is design a process that's economically viable off of the chaos, that assumes the chaos is going to happen instead of trying to control the chaos. And that's that fuzzy middle ground where if we can change our philosophy around how we treat that space, I think we can really dynamically change what happens to intellectual property and how much faster it gets to market and how much sooner we discover those pivots.
So do you think that, obviously you've seen many different university environments where innovation is happening and you work with them to commercialize. Do you think that there's enough being done to teach the scientists how to recognize commercially valuable intellectual property, or just like how to understand the basic concepts behind patenting?
Yeah, I would say that too much is being done to teach them that, which I think is probably a shocking statement to most people because they think exactly the opposite. And I say that for a couple of reasons. One is in the last couple of decades, there's been a dramatic ramp up of efforts to teach and help faculty, and frankly, every inventor at universities. This includes graduate students and undergraduates and staff members, and it's much broader than just faculty. But of course, faculty get this university, so faculty always are the center of the universe for these things. But a tremendous effort's been spent on educating faculty on what this means. Some of it from within the university system itself. The tech transfer offices spend a lot of resources trying to help faculty understand these systems. The National Science Foundation, through their I-Corps program, has spent so much money on this. It's I think almost absurdly ridiculous how much they've spent trying to teach professors to not be professors and instead be business people. And then professors themselves, especially the younger generation, they've seen so many things happen in the startup spaces. They've seen some of their friends make some money, and they get these dreams, and so they self-teach, right? They self-explore. And I think all of that is great, but you can't teach experience in a certain way, right? The act of getting out there and doing it and being beat over the head and hearing these things, it's a different thing. And I'm sure you well know this. You can hear somebody present an intellectual property idea or an invention, and your decades of experience thinking about intellectual property, you immediately frame it in a certain way. These are really, really smart people without experience, so they have to think through every step. And stuff that you and I would just look at and say, oh yeah, this is just it, and we're off and running and doing it. And it takes us 30 seconds to figure out. It takes them 30 weeks to figure out, right? Not because they're not smart, but because this stuff isn't easy.
Yeah, it's definitely very nuanced. I mean, that's what I have. It's interesting what you're saying, because what I was not expecting what you just said, because I have mentored a lot of young scientists, early career, mid-career scientists at Dow and DuPont, they hired phenomenal, smart people. But what I've seen is that they don't know a whole lot about practical patent law. So I'm surprised that they're being taught, because they would soak up everything I taught them, and I would teach them and mentor them. And very quickly, they're really smart. They can get up to speed, but that practical look at things is what I was teaching them. And it's, I took the patent bar, but taking the patent bar didn't teach me anything that I use in my day to day. It was really hard to study for a year to take it and pass it. But working with phenomenal patent attorneys and inventors and Dow and DuPont, who just know the practical elements of what's inventive and what is a customer need, what's the unmet need, then that you can put in a patent, and how to protect trade secrets, the nuances of all of that that's not in the patent law books at all.
No, it's not. And so, do you think that these young people that you were giving some information to or helping, do you think it's the first time they ever heard it, or do you think they had heard it before and they were aware of it? It's just it had never been explained to them the way that you were approaching it, or it wasn't actually a real part of their job, so they didn't pay attention?
None of them told me that they've learned about this before.
Interesting. Really fascinating. Really fascinating, because it is, I think I could go to every major research university and find a program that's involved in helping students and faculty understand the intellectual property process and the business startup process. So it was something I would be very, very shocked if it wasn't something that was available to them. Perhaps they were really smart and decided that they were there to finish their dissertation, and that these other things sidetracked that, and that they should just finish it up and get it done. And plus, what's more miserable than having to go to work for next to no pay and listen to whatever the professor is telling you to do when you really want to do something else? You just want to get it done and get that dissertation approved and move on with your life. So it's interesting, really, really interesting.
Yeah, and also I do think that similar to just technology in a big manufacturing organization in general, they have their certain approach, how they develop their technology, how they do their technology. That's not public information. The same thing, they'll have their approach through patents. So in a way, a big company like Dow and DuPont, they expect to be teaching super smart people these kinds of skills. They don't want to just hire a monkey that will do a certain thing a certain way. They're happy to teach certain things to talented people. So I
Right.
think it's funny. I have a set of courses on reading patents and innovation concepts and trade secrets versus patents. And I developed them, and I had help from my mentors in an IP law group. And I would co-teach it. I would teach, and the attorney would be in the room. And I started doing this Zoom seminars. And I mean, it was during COVID, so people were stuck at home, but I started to have like 900 people come. And I was even joking that no matter what kind of boring title I gave, like confidentiality agreements, like non-disclosure agreements, like would be like, who would want to spend their
Not me.
Thursday evening talking about, but people would come. And then what was the best part was the questions. And so they had really a lot of questions where it was important for our attorney to be in a room. And sometimes those questions we would sideline and say, we need to have one-on-one discussions and not have this in front of the 800 people in the audience. But we had questions from scientists all across the organization, not just the younger scientists. And I do think that I take credit for that, because I do not have the patent attorneys single-handed take on it. I definitely come at this information as a scientist, that I was learning it as a scientist. And so I'm kind of translating in that language when I teach. And then I end up identifying scientists that love patents and will work with me to develop IP strategy to protect key market segments. And that kind of one-on-one work together, it's just fantastic for them to soak it up and become really impactful in the IP space.
Yeah, that's fantastic. And I think we discussed this in chatting with each other when we first met, that the approach of a large company is to think about patenting something when it's time to go to market, rather than, or the timing of the patent is, when is this going to become public, and when do we, when is the last moment we can possibly get around to patenting this? Not, we have an invention, let's go rush to the office and patent it, right? And the university's perspective is exactly the flip of that. It's the second that they smell the opportunity to have a patent, they rush to the patent office to do it. And for two reasons. One is the professor wants to publish. And so if they publish and they have files, there's a problem with that, right? But the second is that for a lot of professors, the act of having the patent is actually the endpoint for them. They're holding it up saying, hey, look, I have a patent. My work is so important that I got a patent for it, right? And it's less about, oh, here, I've got a commercial pathway for this, and I've thought this through, and I realize that this is actually valuable. So it's a really, really different environment.
Yeah. So I have a question on that topic, Ken. One of the main starting points to develop IP strategy is, let's take a look at what the competition is doing, And so I'm wondering, because your competitors' patents will teach you what they're up to. A lot of times they're hiding stuff, but it's in their patents. And I was wondering, do you see people in universities read the competitors' patents?
I think the answer to that is largely yes, but probably not from the competitive intelligence standpoint. Probably more from the understanding prior art and understanding, what the scientific merit of that patent is. And so I believe, I don't, it's infrequent that I meet an inventor at a university who is unaware of the rest of the patent landscape that is in and around what they were doing. Of course, I meet some that are, they're just, egoists that have decided that their invention is all that matters and everything else doesn't. But, so it is a bit of a challenge, though.
Yeah, I mean, I definitely see scientists, they come to me and tell me how long it takes to read patents. And that's because they read patents the way you would read a journal article, which, I mean, actually.
Yes, just like. Yeah.
Which that's just, I mean,
I'll credit AI with at least making it easier to read a patent.
Well, yes and no, but because I don't know, we just did a recent episode. The Pentagon had this garage sale of patents, and they had this really nice website where you could actually click on a patent and it'd give you a one-page summary of that patent. And it's very clearly generated by AI, because it would explain to you what this patent covered based on the abstract. It didn't look at the claim. It was very clear, because we looked at the claim a lot of time. So like the way AI is mining this data, I don't know, is this AI definitely the one that Pentagon was using was not properly trained to look at the broadest
Well,
possible independent claim.
it shocks me that the Pentagon would do such a thing. But two pieces on that, which are kind of in different spaces, but I'll add to it. But obviously, I think if you don't use AI, if you don't use large language models the right way to read that patent, then that's your fault, and you should probably learn something about how it works. But I think it's going to be very valuable. But the Pentagon and the government labs, especially the Department of War labs, right, are really, really interested in this sort of free for all thing they did with the patents. And I think they had some competition too. So you could license one of their patents, pitch it, and they were giving some $20,000 rewards. And I think they've got a big competition right now down in Texas, where they're bringing all those people that won the $20,000 rewards in to give them $500,000 rewards. I know a few people have gotten a few of those, and so they've really kind of tried to figure out a way to make it into something. But it's really, really interesting because the federal labs, especially, or the Army Research Lab, the Naval Research Labs, and the Air Force, is that they are trying to solve a very, very specific problem for the military. And they are really good engineers, and they figure out a really efficient way to solve that problem. And then they file a patent for it. But any decent engineer who was trying to solve that same problem would have solved it the same way. So there's no real underlying intellectual property there. Sure, there's a patent, then a patent is intellectual property. But let's be real about what intellectual property is, what it's valued. It's valuable because you're able to figure out how to do something in the world that nobody else is able to figure out how to do. Right? If you are protecting how to make a small plate on a bulletproof vest, who cares about that for anything other than the small plate for the bulletproof vest? Right?
In fact, you might not want to publish that in a patent application that you're doing that.
You probably would not, but the military's already done that, so then you just copy it and you do what they ask you to do. But it's a little bit like we talk about this again with the surgeon who solves a problem because he's just applied good engineering to a problem that any good engineer would have solved the same way if they understood the problem, which is very different than a scientist who spent his entire life studying how ants move and figures out that he can use that to file a new patent in an area. They know something about the way the world works that nobody else in the world knows. It's much, much, much more likely I could take that patent and make something interesting of it, largely through pivoting. The patent for the medical device or the military device, unless I'm going to make exactly that thing, it's not interesting, right?
Understand. I wanted to bring you to one other topic, and we're getting to the end of this, and this has just been so interesting. But there's a topic we haven't touched, and I want to have your thoughts on the value of trade secrets. And do you believe that patents or trade secrets have more value in a startup or in a new space where the university is working?
Yeah, I'm a huge proponent of trade secrets, and I think I'll even go as far as to say, in most cases, I wish the university would just simply publish what they were doing, and because normally it's so early stage that the time it takes to reduce it to practice and what you actually do to reduce it to practice leads you to better intellectual property and more protectable, more easily protected intellectual property, most likely more narrowly scoped out, but also not filed until you actually need it, as opposed to the open art of it all. And there are places where you can't do that, right? So composition of matter patent for a new drug to attack disease X. Yeah, you file the composition of matter, please, and protect it, and we do all of those things, right? But I'll use an example that we licensed from Johns Hopkins for making ceramics through fusing metal powders in the presence of methane or ammonia, right? So you can make silicon carbide, for example, with silica and in the presence of methane. And look, it was a really kind of unique way to 3D print ultra-high temperature ceramics. They tried to file the generic patent that just sort of comes over all of that. And I think it's now been 4 years and that patent still hasn't issued. And they probably spent I'm throwing the number out there. It's probably not quite that big, but it's, but they spend a lot of money trying to get to that patent. to do it, whatever that number happens to be. And the reality is that within a year of working with those materials, we discovered a better way to fuse it, a better way to make it work within a 3D print environment, and a system by which we don't need the underlying patent. Nobody's going to be able to practice what we can do in a much, much narrower way. And that's still a trade secret. And I feel very comfortable protecting it as a trade secret because you're not going to figure out how to do what we're doing unless you go spend $5 million to figure it out. So if you want to spend $5 million to figure out what we're doing, instead of just paying me to tell you, then, go for it, right? So I think there's a lot at universities where they think they're being smart getting the patent and covering it all. But oftentimes those patents don't issue because they're too broad. Or even if they issue, you would look at them and say, oh, this is a totally worthless patent. It's going to be an irritation that the university has it because at some point they're going to sue me over this thing, but they're going to lose. Right. And they don't get or understand that because they don't go back to your initial point, which is they're not really looking at the strategy of what they're doing. They're just simply issuing the patent because they think they can.
Really, really interesting. I feel like we could go on talking. I have several more questions. Maybe we can have a separate episode, but I wanted to wrap this up for today because our audience usually is comfortable with the 30 minutes. And I just want to say thank you so much. This has been really fabulous. You can find us on LinkedIn. I'm at Thoughtful Thursdays. Innovation Strategy means IP with Tornado IP. And you can find me at tornadoipconsulting.com. Thank you. And Ken, do you have any parting words for where to find you?
Yeah, sure. So you can find me at advantagedmanufacturing.com. And you can check out what we did at Early Charm, EARLYCHARM.com. Located in the charged city of Baltimore.
Yeah, and if you have need help with training or developing IP strategy, come find me. Thank you.
Sounds great. Thanks.